Hi, this is Mr. Adams from Midwood High School. This is a video on Alkane substitution and unsaturated addition. For our purposes, unsaturated refers to not being filled to the max with hydrogen. So if you're not filled to the max, you contain either a double or a triple bond, right? And that refers to alkenes or alkynes. If you're saturated, right, you contain the max number of hydrogens, and you'll have single bonds only between your carbons. All right, so those are two definitions that we should know. Now, the reaction substitution, right, happens with alkanes. Now, they can ask you which particular substance undergoes substitution, or they can ask you to write a simple substitution reaction. So here it goes. Now, guys, this first reaction right here, we have methane, right? And we have a diatomic molecule of chlorine. Now, simply what happens, as its name says, substitution, all that's happening is a hydrogen will get replaced by another atom. In this case, it will be one of the chlorines. So if you have methane, which is CH4, right, with 4 H's around it, okay, one of these H's will be replaced by a chlorine. So what's going to happen simply is one of these H's will be knocked off by one of the chlorines, and you'll form the CH3Cl and HCl. Now what could happen again, this reaction can keep going over and over again, and like they showed over here, but you're only responsible for knowing one of the steps, okay, where one of the diatomic guys substitutes for one of the hydrogens, and you're done. So it's a simple brief explanation of the substitution reaction, which happens with alkane. So you have to know that. All right. The other reaction happens with our unsaturated guys, our alkenes and alkynes. Over here we have alkene, and what happens with alkenes is addition. Now notice simply what happens. Once again, you can have something with two atoms in it. It could be either diatomic or different atoms, but they have two atoms. And what simply happens, you must, okay, focus on the site of the double or triple bond in addition. Now, in this case, we're dealing with alkenes, so we have a double bond. Now, simply what happens, one of these guys from the two-atom molecule goes to one of the carbons. The other guy goes to the other carbon in the double bonds. Now the thing is, you might ask, if I switch the X and the Y around, it doesn't matter. As long as you put both of these guys at the sites where the double bond exists, you're good to go. An example over here, we have bromine, okay, Br2. Remember the Hun group 17 rule, hydrogen, oxygen, nitrogen, and group 17, they're diatomic when they're by themselves. So we have two bromines, Br-Br. Okay, one of them will go to this carbon, and the other will go to the other carbon, producing this guy over here. All right, so you're done. Okay, that's addition. All right, so it goes straight to the site of the double bond. Now another example in the bottom right here, we have HBr. Okay, the H goes over here, and the Br goes to this carbon, the site again of the double bond. Now please notice, guys, that when we do an addition reaction, we go from a double bond to a single bond. Okay, so that's all. Don't forget to do that. Whenever you're adding doing addition reaction, a bond is lost in the unsaturated compound. So we go from 2 to 1 in this case. All right. And lastly, we have alkyne addition. Now, alkynes, once again, refer to triple bonds, all right? Unsaturated with triple bonds between the carbons. Now, it's the same principle. We're going to focus on the site of the triple bond, and we expect that if we do addition, we will lose a bond, so we'll go from a triple to a double bond. So you have to remember that. Now, the HCl over here, simply what's happening, okay, they put the H here, and they put the Cl over here. Now, once again, folks, if we twist it around, it doesn't matter. As long as you went to the correct site where the triple or double bond is, you're good to go. So right now we're focusing on a triple bond, and eventually it turns to a double bond, okay? For the HBr, H and Br, the H went here, Okay, and the Br went over here. Now in this diagram, they put the Br on one side and the H on one side. For our purposes, it doesn't matter. We don't have to do that. When you move on to AP Chem in college, you'll learn about cis and trans conformations and stuff like that. But please don't worry about that right now. Okay, that's for later on. All right, so the cis and trans and whatnot, that's later on. But for our purposes, we focus on the site of the double or triple bond and put them in the correct place. They have Br2 right here, two bromines together, a molecule. Okay, one bromine goes to this carbon, the other bromine goes to this carbon, and notice once again we have triple bond going to a double bond. Okay, so it's nice, it's simple. Addition reactions happen with your unsaturated guys, and last one is iodine, I2. All right, so it's adding to the triple bonds. Okay, once again, and you get a double bond out of it with the I's at the sites of the original triple bond turning to a double bond, and you're done. All right, so there's two simple reactions, guys. We did alkane substitution. Okay, that happens with saturated guys. Substitution saturated. That's your memory device right there. And unsaturated addition, right, which happens with double or triple bonds. Hard work plus sacrifice equals success. Hope this video was a help. Take care.